Hello everyone, welcome to my presentation about energy saving by adapting passive house buildings in warm climates, a case study of Vietnamese housing. A traditional design approach for tropical architecture is the use of natural ventilation to provide thermal comfort for occupants, especially in residential buildings. However, the reality in most urbans is like what's in these pictures. The impacts of global warming, urbanization, urban heat island effect, air and noise pollution, and the lack of wind make natural ventilation in many cases not an effective solution. Therefore, there is a need for an alternative approach to improve thermal performance of housing in warm climates, including Vietnam. One of advanced solutions is the use of passive house approach. Passive house buildings use mechanical ventilation systems, but can save up to 90% of energy consumption compared to conventional buildings. They can provide comfortable temperature from 20 to 25 degrees Celsius all year round, and provide fresh, healthy indoor air and silent spaces. So passive house could be a potential solution, replacing the conventional natural ventilation technique. However, the specification of temperature set points of 20 and 25 degrees Celsius in passive house for all climate zones should be carefully considered. A number of studies found that people in different climates have different thermal comfort zones. Therefore, the hypothesis of this study is that adopting a higher thermal comfort zone for warm climates would be more appropriate for local residents while saving more energy compared to using the 20 to 25 range. In addition, the passive house standard could be achieved using simpler and more affordable materials. This study firstly conducted an experiment to investigate the thermal comfort zone for the Vietnamese. 8 experiments with air temperatures being set from 23 to 30 degrees Celsius were undertaken with the participation of 128 students. A total of 640 responses were collected and analyzed. Please read the full paper for detailed information of the experiment. The analysis showed that the thermal comfort zone for the Vietnamese is from 23.7 to 29.6 degrees Celsius. This comfort zone is in line with the results of other studies and Vietnam standards. However, this range is significantly higher than the range of 20 to 25 of the passive house standard. In next steps, simulations using the passive house planning package were carried out, firstly to investigate the potential of passive house application in Vietnamese housing. The Vietnamese existing housing without thermal insulation results in a poor thermal performance. The below charts show that when applying the passive house standard, this housing model significantly reduced around 80% cooling and dehumidification demand. These figures show the energy saving from using higher thermal set points, replacing the 20 and 25 degrees Celsius, while preserving the same building properties. It can be seen that the cooling and dehumidification demand reduced by half in both houses. This table shows the building properties of the terrace house that satisfy the passive house energy criteria for the hot humid climate of Vietnam. The numbers in this table show that by using a higher set point, The insulation layers are much thinner, the windows are simpler, and the airtiness requirement is easier. As a result, the construction cost will be significantly cut down. And the same thing happened to the detached house. In conclusion, a case study in Vietnamese housing showed that adopting a higher thermal comfort zone for passive house buildings in warm climates can significantly reduce the energy demand and construction costs of the buildings. Therefore, this study facilitates the expansion of the passive house approach to warm and hot climate areas in the world. That's it for this presentation. Thank you for listening.